Hello, Luke. Welcome to lesson 24. So today we're going to be learning about the multiplicative property of equality. And this is actually kind of a continuation of lesson 23. So in lesson 23, we talked about the additive property of equality. And today we're talking about the multiplicative property of equality. So these two lessons are very similar to each other. It's just before we were talking about addition, and today we're going to be talking about multiplication. But just as a quick refresher, lesson 23, we were talking about equations. So if I have something that looks like x plus 2 is equal to 8, all right, we learned in lesson 23 that there is something that's called the additive property of equality, which means that we can add anything we want to this side of the equation, so long as we add it to this side of the equation, and that will not change the solution for x, all right? So again, I can add anything I want. So I could add a 5. So if I add a 5 to one side, x plus 2 plus 5 equals 8 plus 5. I have to add 5 to that side as well. I end up with x plus 7 equals 13. And this is an equivalent equation, an equivalent equation to our first one, which means that the value of x, the number that's hiding behind x, has not changed. It'll still remain the same value, and it will be a solution to this equation. All right. So we might already recognize that the value behind this x is a 6, right? Because 6 plus 2 is equal to 8. We're just kind of knowing that because it's such an easy problem. We know that 6 is what the x stands for here. But notice that that 6 is also what this x stands for. 6 plus 7 is equal to 13. So that value of x did not change, even though I added a 5 to both sides of the equation. That is the beauty of the additive property of equality. That's what it says that we can do. We can add numbers to both sides, and we don't change the solution for x. All right, so that's what we learned last time. And then we kind of continued that by saying, well, if that's true, then let's use this to our advantage. Our goal, as always in equations, is to get x by itself. So knowing now that I can add anything that I want, and it won't change the value of x, I could choose something that would be advantageous to me. So if I'm trying to get x by itself, I might decide to add a -2, because in adding a -2, that will give me x all by itself. So again, I'll just rewrite the equation. X plus 2 is equal to 8. If I'm going to add that -2 to this side, I have to do it to this side. And then combining these, we recognize those drop out, they disappear, and we have 8 minus 2, which is indeed 6. So by using the additive property of equality, I was able to produce an equivalent equation which has x all by itself. And whenever x is all by itself, then that's telling us what x is equal to. So it kind of unveils the x. It reveals the mysterious number that's hiding behind the x, which in this case, as we already determined, was a 6. All right. So we used that additive property of equality to our advantage. Now, today, we're going to be doing something similar, only now we're going to be using multiplication. That's why it's the multiplicative property of equality. So if I give you another equation, let's say I give you 2x is equal to 8. We recognize that we have multiplication here. Over here we had addition. Here we have multiplication. So if I'm trying to get x all by itself, there's nothing that I can add to this side that's going to remove this 2. I could try to add a 4, 2x plus 4, and then I'd have to do the same thing on the other side, equals 8 plus 4. But that wouldn't help me. I would just end up with 2x plus 4 equals 12. Now that is an equivalent equation to the first one, but in fact now the x is even less so by itself. There's more items, more numbers going on over here. And that 2 was not eliminated. We're not getting x by itself, all right? Because these are not like terms. We can't add them together, right? So when we have multiplication, when the variable is being multiplied here, the additive property of equality doesn't actually help us. It doesn't produce an equation that would leave x all by itself, right? So that is not helpful, and that's where we have to recognize that when we have multiplication, we can use a different property, the multiplicative property. Now, the multiplicative property is pretty simple. All we're trying to do is undo this multiplication going on here, 2 times x. And if you remember, what is the inverse for multiplication? In other words, what's the process that we would use to undo multiplication? And the answer is division, right? The opposite of multiplication is division. So here, if we're trying to undo this multiplication, we're going to use division to do that. Now, how would we set that up? Well, one way to show that would be to take this 2x and divide it by 2. Now, remember, in algebra, we don't like this symbol, okay? We don't use this symbol hardly ever, if ever, in algebra. Okay, it is a symbol that you would have used in grade school and everything else for division. You might have also used the long division form, which we do use in algebra periodically. But when we're talking equations, division, we want to think of division as a fraction. So, you know, some number over some number, all right? That's what we're thinking of when we think of division. We think of it as a fraction, a divided by b, okay? That's the best way to look at that. So if we have 2 times x and we're kind of going to try to divide out the 2, undo the 2, we're going to divide this by a 2. And notice I'm essentially setting it up as a fraction with a 2 in the denominator. 2 times x divided by 2. All right, that's the way that we're going to write these. All right, so now we have to do that to the other side. Remember the golden rule to algebra. What you do to one side, you have to do to the other. So 8 divided by 2 as well. And again, I'm setting that up as a fraction. All right, note how I'm doing that. Make sure you do that on your homework. All right, now we can simplify. So these cross out. The 2 divided by 2 is just a 1, right? So we end up with a 1x, all right, equals 8 divided by 2, that's easy. That's 4, right? Now remember, this 1 times x, another way to write that is simply as an x, right? Because there's always that invisible 1 right next to that. So 1 times x is just going to be an x. Now we have x is equal to 4, right? There we have an equivalent equation. And we know it's equivalent because I've told you so. Because we're using the multiplicative property of equality. I'm not going to prove that the multiplicative property of equality actually will produce an equivalent equation. I am just going to ask you to take that on faith, that when we undo multiplication, and we do that by dividing on both sides, we will in fact end up with an equivalent equation, which again means that this x hasn't changed. It's still representing the same hidden value that it represented it up here, and it still would produce a true equation. So you're going to have to take that on faith. We won't get into the guts on how that works. But know that this equation is in fact an equivalent equation to this one, all right? The original 2x equals 8. So the beauty on this equation, though, is that x is all by itself. And because it's all by itself, we know what x is equal to. We know it's equal to a 4. And if we wanted to check that, let's go back up and evaluate that. Let's plug in that 4 for the x. You'd have a 2 times the x, which is a 4, equals 8. And of course, 2 times 4 is in fact 8. So 8 does equal 8. It is a true equation. And 4 is a solution for x. All right. So what that actually means is, again, just to stress what we're doing here, if I have that equation 2x equals 8, just like in addition, I can also do the same thing with multiplication. I can multiply this side by any number I want, as long as I do it to this side as well. And the x will not change. The value of x will not change. So if I took 2x and I multiplied it by a 10, let's say, all right, take both sides, multiply it by a 10, all right, 2x times 10, well, that would be, multiply the coefficients, 20x equals 80. And lo and behold, if I told you that, based on what we know up here, x is equal to 4, 20 times 4 is in fact 80. All right, so the value of x didn't change, even though I multiplied both sides by a 10. All right, so again, the moral of the story here is, for any equation, we can multiply both sides by any number we choose, and it won't change the value of the variable x in this case. Okay. And so we then just decide what to multiply things by in a way that would produce an equation that has x by itself. Or divide, and I guess I've been using those two interchangeably. This rule applies to division as well as multiplication. All right, it works for both of them. Think of it in the same way. So up here we actually divided by a 2. Here we actually multiplied by a 10. Division and multiplication, just like in addition and subtraction in algebra, they're essentially the same process. It's just the numbers that change. So for example, if I have 10 divided by 2, we might think, oh, that's division. Well, it is, but I could also think of that as a form of multiplication. I could think of it as 10 times 1/2. All right, and do you see how 10 times 1/2 is equal to 10 over 2, right? Which is what we have up here. So division and multiplication, you can always write them in the opposite way. Okay, I know that might be confusing. Hopefully it's not. Either way is fine. So maybe to step back here, and if we look at that 2x equals 8 again, here I divided it by the 2. I undid the multiplication. I divided it by a 2. You might also say, to get rid of that 2, let's get rid of it by means of multiplication. And to do that, I would need to recognize that if I take 1/2, multiply it by the 2x, and of course I have to do that on both sides. I have to take the 1/2 times it by the 8. Notice here I'm multiplying. I'm not dividing, I'm multiplying. But we're going to get the same result. 1/2 times 2x. Well, that's just 1/2 times 2, which of course is just 1, times x, which is just x. So 1/2 times 2x is just going to produce x, right? And then 1/2 times 8, well, that's going to be 4. What's 1/2 of 8? And so we end up with the same answer here. So we can use multiplication like we did here, multiplied by 1/2, or we can use division. Whichever one makes the most sense to you is fine. It's the same process. Okay. So let's try a couple of these and see how we do. So let's say if I've got 6x equals 36. What am I going to do? Well, this is very similar to our other problem. So we have 6 times x. There's two ways that we could approach this. We could, to get rid of this 6, what could we multiply it by? And when you think about that, you need to think about 6 times what is going to give us 1, because that's what we're after. If we can get the 6 to be a 1, we'd have 1x, which is just x, which is what we want. We want x to be all by itself. So 6 times what is equal to 1? Well, then you have to go back to remembering your reciprocals. What's the reciprocal of a 6? The reciprocal of a 6 is 1 over 6, right? And recall that whenever you take a number and multiply it by its reciprocal, you're always going to end up with 1, right? If I were to put this as a fraction, these cross out, and we end up with a 1, right? So to get x by itself, we can multiply this coefficient by its reciprocal, which is 1 over 6. So 1 over 6 times 6x equals 1 over 6 times 36, right? And then again, and maybe we'll just switch colors here. So we can mark this as a fraction if we would like. The 6's, they're going to cross cancel each other out. The 1's are obviously just 1's. So we end up with 1 over 1. Maybe we'll throw a 1 here. 1 over 1x, which is just an x. Right? And then on the other side, we have 1/6 times 36. Well, we could write this as a fraction, right? 36 over 1. These would then cross cancel. 6 can go into itself once. 6 can go into 36 6 times. And we end up with 1 times 6 is 6 in the numerator. 1 times 1 is 1 in the denominator, which is equal to just a 6, right? So x is equal to a 6, which if we go back and check, 6 times x, which is a 6, 6 times 6 is in fact equal to 36. So we know we did it right. All right. So that would be one method of solving this problem, multiplying that coefficient by its reciprocal. Now, another way to solve this problem, and it is equally, maybe even more so, it's even better maybe, it's equally as good, 6x equals 36, is to do what I said earlier, which is to think about this in terms of division. So 6 times x, well, I want to undo that, and I can undo it by what we did up here, multiplying the coefficient by its reciprocal. Or I can just think of it as 6x, well, I want to divide out the 6. So I'm going to get rid of the 6. I'm going to divide it out because that'll give me a 1. But that means I have to divide this side by a 6 as well. And if I do that, these 6's cross cancel out to a 1, which gives us an x, and 36 divided by 6 is actually 6. All right, and notice we got the same answer. And I even think this is faster and easier when we do it this way. So whenever I see multiplication like this, I tend not to think of it in terms of reciprocals when we're dealing with whole numbers. So when we're dealing with whole numbers, I tend to think of it as just multiplication, and I want to undo it by division. Okay, so I would have approached it this way. I think it's just faster and easier. All right, but if you prefer to use the reciprocal route, multiplication instead of division, that's fine too. You would get the same answer. All right, so let's try another one here. And let's actually do one where it might make more sense to use the reciprocal route instead of the division route. So let's think of an equation that has fractions in it. So if I have 1/2 x equals, 3/4. Okay, there's my equation. And again, we notice that to get x by itself, we need to undo this multiplication going on here between the 1/2 and the x. And again, we could do that by one of two ways. We could multiply this coefficient by its reciprocal, like what we did in this first problem over here, or we could divide this by its reciprocal, like what we did in the second part of this first problem. Okay, either one of these ways will give us the right answer. But in this case, it's a fraction. And because it's a fraction, I would probably prefer to use the first method, the reciprocal method. Okay, it seems a little bit easier that way. So what we're going to do is we're going to take this this coefficient and multiply this side of the equation by its reciprocal. So what is the reciprocal of 1/2? Well, the reciprocal of 1/2 is 2/1, right? We just flip-flop. We just trade the numerator and the denominator. So we're going to multiply this side by a 2/1 times our, and maybe I'll just switch back to this so we can see where the original equation is. 1/2 x equals 3/4. And again, we need to multiply that side by 2/1. Okay, 2/1, 2/1. We're doing the same thing to both sides. Now we can work this out. These are going to cross cancel, right? And we end up with, 1x, which is just an x, equals, now over here, we've got this already set up so that we can multiply it pretty easily. So this can cross cancel. It can go into itself once. 2 can go into 4 twice. And that's going to give us 3 times 1 is 3 in the numerator. 2 times 1 is 2 in the denominator. So x is going to equal 3/2. Okay. So there you see where we used the reciprocal, and the reason we used the reciprocal method is because we're dealing with fractions. It's actually a little bit easier. Now, I could have done this the division way, so I'm going to rewrite the problem. 1/2 x equals 3/4. Okay, and now I could say, well, this is multiplication, and I want to undo it, so I'm going to divide this by 1/2. And you see how this is already becoming a little bit messier because of the fractions. We've got to divide both sides by 1/2, and we've got these big, nasty division by fractions over here. So you might recognize, though, that again, it's not too bad. 1/2 divided by 1/2, well, anything divided by itself is 1. So these will just cross each other out, and we're going to be left with an x, right? Now, 3/4 divided by 1/2. Now, we kind of have to go back to our old way of doing things and think of this as 3/4 divided by 1/2. And if we're going to do that, that has to become 3/4 times 2/1, right? Because we flip this, we take the reciprocal of it and change the division to multiplication. Then we can cross cancel, and we get 3/2. Okay, so 3/4 divided by 1/2 is in fact 3/2, and we get the same answer. I don't know. I look at this as being a little bit more work over here. Because you had to invert the fraction and set it all up in the kind of the sidelines over here to get your final answer. I find it a little bit easier to use the reciprocal method, such as what we have here. All right. So I guess if you're looking for a rule of thumb, I would say if the variable has a coefficient that's a fraction, well, then multiply it by its reciprocal. You could divide it by its, the coefficient, that's fine, but it's usually a little bit easier to multiply it by its reciprocal if the coefficient is a fraction. If it's a whole number, like over here, I find it a lot easier to actually divide, use division to divide out that 6 or that coefficient, all right, instead of using the reciprocal. So if it's fraction, use the reciprocal. If it's a whole number, use division. All right. Hopefully that makes sense to you. So I think we'll just try a couple of problems here, and I want you to try to work these out on your own, and then we'll do it together and just make sure that we understand how this works. So we'll start with an easy one. Let's start with 5x equals 20. Go ahead and pause the video and try to solve this on your own. All right, so hopefully that one was easy for you. Again, we're dealing with a whole number, so I'm going to use the division method. This is being multiplied, so we're going to divide this out by a 5. 5x divided by 5. That's what we're going to do to get rid of the 5. But we have to do the same thing over here. So that's going to leave us with an x is equal to 20/5, which is 20 divided by 5, which is 4. And there's our solution. Very clean and easy right there. All right, let's try another one here. And again, I'm going to have you pause the video here and try it on your own. Let's do 2/5 x equals 7. Okay, pause the video and try it on your own. All right, now let's try it together. 2/5 x equals 7. Now notice here we have a fraction. That's the coefficient, okay? And because of that, I'm going to use the reciprocal method. So I'm going to multiply this side of the equation by the reciprocal of the coefficient, okay? 2/5. The reciprocal would be 5/2. I have to do the same thing over here. All right. Now the beauty is that this is going to cross out and become a 1, so we have an x all by itself. Now I have 7 times 5/2. Well, let's turn this into a fraction, 7/1. There isn't any cross canceling that I can do here. So I end up with 7 times 5, which is 35 in the numerator, and 1 times 2, which is 2 in the denominator. Now I could make this into a proper fraction or a mixed number in this case, but I'm happy with improper fractions. In algebra, we're not too picky about what that fraction looks like. So we're going to leave it just like that. X is equal to 35/2. All right. So again, I notice again that I used the reciprocal method here. Over here I used the division method based on what the coefficient was. All right, let's try another one. How about 2 1/4 x is equal to 3. All right, pause the video, give it a try. All right, so this one, we will begin by first taking this mixed number, and I'm curious to see what you did on this one, but I think the easiest way to do it is to take these mixed numbers, and the very first thing is to just turn them into improper fractions. They're just a little bit easier to work with. So let's change that into an improper fraction first. 2 times 4 is 8, plus 1 is 9, so we have 9/4 x equals 3. All right, and now it's just a little bit easier to work with. So again, we could divide this by 9/4 and the 3 as well, or we could, because it's a fraction, we could multiply it by its reciprocal, which I think is easier. So we'll multiply it by its reciprocal on that side, multiply it by its reciprocal on this side, and now what happens? Well, these cross out to a 1. You have an x equals, now I can turn this into a fraction. Now here we can do some cross canceling, right? 3 can go into itself once, 3 can go into 9 3 times. And what do we have in the numerator? Well, 1 times 4 is 4. In the denominator, 1 times 3 is 3. There we are. It's as simple as that. All right. Excellent. Let's try a harder one here. Or not necessarily harder, but just a little bit more unusual. How would you attack something that looks like this? So look at that one for a minute and see what you can do. How would you attack something that looks like this? So let's look at this and first just see what we're doing. What we're doing is we're taking an x and dividing it by 3, right? So once again, we're trying to get x all by itself. So if the operation here is x divided by 3, how could we undo that operation? And remember, how do we undo division? We undo it by multiplication, right? So if x divided by 3 is what we have, couldn't we undo that by multiplying it by 3, right? So we're dividing the x by 3. Well, let's try to multiply this side by 3 to undo that division by 3. But remember, if we do that on that side, we have to do it on this side, right? Now we recognize that, hey, this is actually going to work because the 3's are going to cross cancel each other out, and we end up with just an x. And then on the right side, we have 9 times 3, which is 27. So x is actually equal to 27, which makes sense. If you plug it into the equation in the beginning, the x is now a 27. So 27 divided by 3 is in fact 9. So that's perfect. It's exactly what we're looking for. So when you see that variable in the numerator, x divided by 3, just think, how would I undo that? I'm taking an x and dividing it by 3. Well, to undo it, let's multiply it by 3. All right? Excellent. All right, let's look at another one here. What about, and I'm taking these right from the book actually, what if we go x over 2 1/2 is equal to 7. So again, getting a little bit more complicated. How would you attack this? Any ideas? Look at it and maybe pause the video, try to do it on your own, see what you come up with, and then we'll go through it together. All right, so looking at this, remember what I said earlier. Really the first step is to just get rid of these mixed numbers, okay? Let's just write those as improper fractions. So we have x over 5/2, right, is equal to 7. Okay, so now we've gotten rid of that. Now let's look at what we're doing here. So we're taking an x, we're dividing it by 5/2. So it's very similar to this problem. We have an x, we're dividing it by 5/2. So how would we get rid of that? Well, to undo division, we do multiplication. So if we're dividing by 5/2, let's multiply it by 5/2. Take this side and multiply it by 5/2. This side would also have to be multiplied by 5/2. All right. Now, if you think about it in terms of this 5/2, you might think of this as 5/2 over 1. All right. I know that's kind of odd, but we could think of this as 5/2 divided by 1. All right. And 5/2 divided by 1 is still 5/2. We're not changing anything, but we're just thinking of it as 5/2 over 1. And the reason we're thinking of it that way is it's a little bit easier to see that this 5/2 and this 5/2 can actually just cross cancel each other right out, right? And they can become a 1, right? Hopefully that makes sense. You see how that works? So we're cross canceling out the 5/2. We end up with a 1x, which is just going to be an x on this side, and then equals, now here again we have to put this over 1, and now we can't cross cancel anything, so in the numerator we have 7 times 5 is 35. In the denominator we have 1 times 2, which is 2, so we end up with x equals 35 over 2. All right, so again, it looks a little trickier because we have fractions in there, but just remember, fractions, they're just another number. So treat them like a number, right? So x divided by this number, how do we get rid of that number? Well, we multiply it by that number. We undo it. We divided by it, now we're going to multiply it, okay? And then they will cross cancel each other out, all right? So hopefully that makes sense to you. Give the problems today in your homework a shot, see how you do. If we need to go over some more of these, we will, but we'll be doing these till you can do them in your sleep. Okay. So good luck on the homework, and I will see you in lesson 25.